for silicon controlled rectifier. This device is made up of silicon and it acts as a rectifier, and the operation of rectifier can be controllable. So that's why it's called SCR, silicon controlled rectifier. We are going to see its generic family name is thyristor. Particularly this device is known as SCR. And this is the structure of SCR. It has 4 layers, P, N, P, N. So P layer as well as N layers are arranged in alternative manner, and it has 3 terminals: anode, gate, cathode. In some textbooks you may find this C, cathode. So in a crisp, if we say SCR is a 3 terminal 4 layer PNPN semiconductor device. And see, this is the symbol of the SCR. Its symbol is nothing but the diode. You can see this one, this triangle and one line. In addition to the diode symbol, it has a gate terminal. This is the symbol of the SCR. And the operation of SCR can be explained with the help of the VI characteristic of the device. SCR has 4 operating modes. That is, in this section we can say it as a forward blocking mode, and here it is a forward conduction mode, reverse blocking mode, reverse conduction mode. So this is the SCR, and this anode to cathode is a positive terminal. If you are applying a positive voltage to anode terminal with respect to cathode, these 2 junctions J1 and J2 become forward biased. Anode to cathode. This is this voltage, VA voltage. Whenever we are applying a voltage to anode to cathode terminal, this P becomes a positive here itself. So this PN junction becomes forward biased, and this junction becomes a forward biased. Cathode N terminal is negative, so P is positive terminal. So these 2 terminals are forward biased, whereas junction J2 is in reverse bias condition. And whenever we are applying a active, so till the time it will not connect only with anode to cathode voltage. The current flow will not happen throughout the device. If you apply a voltage, small amount of voltage across the gate to cathode terminal, if you apply a small voltage from gate to cathode terminal, here, these are the gate terminals. So it will turn down from off state to on state. It is forward blocking state into forward conduction state. And this is the forward breakover voltage. So we should not exceed more than this voltage. If we exceed that voltage, the device will become failure, or avalanche breakdown happens to the J2 junction, so the device will become failure. And you can observe these 2 things: latching current and holding current. Latching current, this point is known as a latching current. Remember one thing, always latching current will be more than the holding current. Mostly latching current will be 3 times the holding current. So latching current is the minimum current required to turn on the device. That is, minimum current required to turn on, to shift from forward blocking mode to forward conduction mode, and it associated with the turn on process. What is the holding current? Holding current is nothing but the minimum current we need to maintain so that the device is in on condition. If the anode current is less than holding current, it will become turned off. That is, on state into off state it will be. So this is the important 2 currents associated with the characteristics. And come to the reverse biased characteristics. Whenever we are applying a reverse voltage, that is, anode is negative with respect to cathode. Whenever anode is negative with respect to cathode, see the characteristics. A small amount of leakage current will flow in terms of microamperes or milliamperes. So up to this point, reverse recovery current, reverse recovery voltage. Up to this point, a small amount of leakage current will happen. If you are increasing the voltage further, a reverse voltage will happen across the. See, whenever we are applying a reverse voltage, both junction J1 and J3 are in reverse bias. Only junction J2 is in forward bias. So if you're increasing the voltage beyond this value, avalanche breakdown happens both in this junction J1 and J3, and the current flows from here to here in opposite direction. So that leads to the failure of the device. This is the VA characteristic of the SCR. Yeah, thanks for watching this video.